Right, today we're going to prove that root 2 is irrational. So we're going to set out to prove that root 2 is an irrational number. Well, in order to do this, we need to know what a rational number is. And a rational number is a number that can be represented as a fraction. So we're saying that root 2 cannot be represented as a fraction. Now, if you want, I could use the P over Q in the formula book, the fraction P over Q, or I can just write down A over B, where A and B belong. Well, root 2 is a positive number, isn't it? So I can say where A and B belongs to the integers, or I could say where it belongs to the natural numbers. It actually doesn't matter. But I suppose to play it safe, where A and B could belong to the integers. We are also going to do this. What's the first thing we do when we're given a fraction in mathematics? And I'm going to give you a bit of an example here. So, I'm going to have, let's get this one right, 12 over 8. Come on, be honest with me. What's the first thing we always do if we see the fraction 12 over 8? Well, we either rewrite it straight away or we tap it into our calculator and see what the calculator gives us. But whatever, we end up rewriting it. So what is 12 over 8? What goes into 12 and 8? 4. So how many times does 4 go into 12? And how many times does 4 go into 8? And in national school, when we did this, we were writing the fraction in its lowest or simplest form. Yeah? So without any loss of generalization, A over B is in simplest form. Now, if something is in simplest form, that means no common factors. Yeah? Is that happy with everyone? Now, you could say, but hey, hang on a minute, how can you say that? Well, I said, well, because I'm saying it. Well, you say, well, what happens if it isn't? All right, I'm going to cancel it down. All right, I'll cancel it down. So therefore, I'm going to cancel it down, and it's now equal to P over Q. You see what I'm getting at? Still algebra, isn't it? So, I'm pretended I've already done that. I've already cancelled it down, and the algebra has cancelled down to A over B. And that's without any loss of generalization. Is everyone happy with that? Okay. So we have to show that root 2 cannot equal a fraction in its lowest form, or any form for that matter. But if it was in any form, we'd be cancelling it down to its lowest form anyway. So it cannot equal A over B. What do we know about A over B? There's no common factors. There's nothing that goes into A that also goes into B. That's key to this proof. That's why we had to say A over B is in its simplest form. Now, let's get on with the proof. We're going to employ a proof by contradiction. Now, this only works in one simple situation. The lights in this room are either on or they're off. Something is either irrational or it's rational. It is or it isn't. You've heard this expression before. In mathematics, if you go on to further study, it's called a dichotomy. And when you have a dichotomy or a dual situation, you can actually offer an opposing argument. So what I'm going to do is I'm going to prove it by offering the fact, let's suppose it is rational. So let's assume it is rational. So assume root 2 is equal to a over b. It's rational. Now, when we've got square root symbols in our mathematics, what's the first thing we always do to move it on to the next line? We square it. So now, you probably don't remember this, but when we square something, technically, we square everything on the left and we square everything on the right-hand side. So therefore, 2 is now equal to a squared over b squared. Now we're following our nose. What else do we not like in mathematics? So what are we multiplying by? B squared. So on the left, we're going to get 2b squared, and on the right, I'm going to get a squared. What's special with a number which has got a 2 in front of it? A 2 times in front of it. Think about it. What type of number is it? Always. No argument. Even. Because we've got 2b squared, 2b squared is even. But 2b squared is equal to a squared. So what does that mean about a squared? It's even. So therefore, we did this the other day, by the way, a squared is even. A squared is definitely even. Now, what type of number, when you square it, always gives an even number? So pick one. Pick an even number, pick an odd number. It's always even. 2 2s, 4. 3 3s, 9. So odd on odd is odd, always. Even on even, always even. So as a consequence of that, because a squared is even, a is also even. This implies, if a is even, that it can be written as a multiple of 2. Because all even numbers are multiples of 2s, aren't they? I'm now going to square both sides. So if I square both sides, what does a squared equal? Well, if I square both sides, I'm squaring the a, and I'm squaring all of the right-hand side. So therefore, a squared is 2m on 2m, and 2m on 2m is 4m squared. Oh, sorry, where m belongs to the set of natural numbers. That's very important. M can't be a decimal. To be an even number, it's double an ordinary number, a counting number, or a Z number. You won't lose marks for calling it a natural number. What I'm going to do now is I'm going to go back in and substitute for the a squared. But a squared, based on my logical argument on the exert or the insert to the right-hand side, is equal to 4m squared by logic. Have I made any mistake anywhere? Except for my first assumption, my line 1 assumption, have I made any mathematical errors? Unusual for me, but true. No, not one. Every single line is mathematically correct. Oh, hang on a minute. 2b squared is equal to 4m squared. What can I now do? Divide across by 2. If I divide across by 2, I get b squared is equal to 2m squared. Hang on a minute. What does that imply about b squared? What does that imply about b squared? It's even. I don't think we need to go through all the arguments above, because it's the same argument, isn't it? If b squared is even, what do I now know about b? It's even. If b is even, that implies that b can be put equal to something that's a multiple of 2, can it? Now, we've already used m earlier on, so this time I'm going to say, keeping in line with the alphabet, I'm going to say 2n. B's equal to 2n. Is that right? So root 2 is now equal to 2m over 2n. What's the problem? There's a common factor in it. But what did we do on line 1? Did we not already eliminate the common factor? We cancelled it out at the very beginning. We put in a fraction in its lowest terms. But I haven't made any mistakes, have I? Not one mistake have I made, but I've ended up with a fraction not in lowest term, which can't be. That cannot be. So where was the only place I could have made the mistake? At the assumption. This is a dichotomy. I made an assumption. I didn't make any mistakes. When I got to the very, very, very end, I got a wrong answer. I got a wrong answer at the very, very end. So therefore, there must have been a mistake. And the mistake could only have been at the very, very beginning. And that's proof by contradiction. So therefore, I am contradicting that contradicts this. Therefore, root 2 cannot equal a fraction in its lowest terms. It cannot equal it. Therefore, root 2 cannot equal. It has to be the opposite of what I assumed. Therefore, proof follows by contradiction.